नमस्ते सबैजनालाई। आज हामी एरोमेटिक हाइड्रोकार्बनको बारेमा केही कुरा डिस्कस गर्दैछौँ। सो एरोमेटिक हाइड्रोकार्बन आर अल्सो कल्ड एरिन्स. So the word aromatic is derived from the word aroma, which means pleasant smell or sweet smell. So the compound having sweet smell or pleasant smell and obtained from natural source are called aromatic compound. The chief source of aromatic compound is coal tar and petroleum product. General formula for aromatic compound is CxH2x minus 6y, where X is the number of carbon atom, Y is the number of ring in molecule. So the traditional definition of aromatic hydrocarbon are those compounds which have pleasant smell, good fragrance, sweet smell and can be obtained from natural source. But the definition was not complete because there are many organic compounds which are aromatic in nature but do not have sweet smell, which do not have pleasant smell. Some of the aromatic compound might have unpleasant, pungent smell as well. That's why the definition was not complete. So the aromatic compound are those compound which are cyclic, planar and obeys Hockel's rule. That is 4n plus 2 pi electron system. So let's move to the Hockel's rule of aromaticity. The rule that deals with the aromatic character of compound and helps to decide whether the compound are aromatic or not is Hockel's rule. According to Hockel's rule, a compound is said to be aromatic if it is in conjugation and have 4n plus 2 pi electron system, where n is non-negative integer starting from 0, 1, 2. So let's see how benzene is aromatic, how naphthalene is aromatic, how anthracene is aromatic. So in order to be a compound to be aromatic, it must be cyclic, it must be planar, it must have conjugation and it must obey 4n plus 2 pi Hockel's rule. So in case of benzene, the compound is cyclic as we are seeing here, and there is good conjugation pi, sigma, pi, sigma, pi, sigma. And another condition is planar. The benzene is planar, that is it is easily drawn in 2D. It is 2D figure, that is all the carbon of benzene are sp2 hybridized. That's why it is planar as well. So another condition for aromaticity is Hockel's rule. So when the value of n equals to 1, there will be 6 pi electron which satisfy the Hockel's rule. So the benzene is aromatic compound. In the same manner, naphthalene is an aromatic compound because there are 1, 2, 3, 4, 5, 10 pi electron system. So we will get the value 10 pi when n equals to 2. n equals to 2, we will get the value 10 pi in the equation 4n plus 2. That is 4 into 2 plus 2 equals to 4 to the 8 plus 2, 10 pi. So this is aromatic. In the same manner, naphthalene, there are 14 pi electron. When n equals to 3, we will get the value 14 pi electron in 4n plus 2 pi electron system. 4 into 3 plus 2, that is 12 plus 2, that is 14 pi electron system. That's why anthracene is also aromatic compound. Anti-aromatic compound. So anti-aromatic compound are those compound which are cyclic in nature, planar, conjugation and obeys 4n pi electron system. Aromatic compound has three properties same as anti-aromatic compound has three properties same as our aromatic compound, but it must obeys 4n pi electron system. So here I have kept cyclobuta 1,2 diene as an example. So this is cyclic in nature. There is conjugation as you are seeing here, pi, sigma, pi, sigma, pi. This is pi bond, this is sigma bond, this is pi, again sigma. There is a good conjugation in the ring. This is cyclic, conjugation, and all the carbon are sp2 hybridized. Here we have 1 sigma, 2 sigma and hydrogen is here. So we have 3 sigma, that's why sp2 hybridized carbon. All the carbon are sp2 hybridized and it obeys 4n pi electron system. That is n equals to 1 2 3 natural number, positive natural number, but in that case the value of n will not be 0. So there are 1 to 4 pi electron, 4 pi electron, that is 4 into 1 equals to 4 pi electron. That's why this is anti-aromatic compound. Now move to non-aromatic compound. Compound which are neither aromatic nor anti-aromatic are called non-aromatic compound. Here we can take normal organic compound, that is CH3 ethane, that is 1 2 3 4 1 comma 3 butane, buta 1 comma 3 diene, and cyclohexane. These are non-aromatic compound. So I have written here in two line stability order. The most stable compound in the organic chemistry are aromatic compound, after that non-aromatic compound and anti-aromatic compound. So the most stable is aromatic compound and the most unstable is anti-aromatic compound. And the reactivity order will be just reverse. Which one is more unstable, that is going to be more reactive. That is, anti-aromatic compound are going to be highly reactive, whereas non-aromatic will be intermediate and aromatic are least reactive because they are highly stable because of the resonance. Let me discuss some example of aromatic compound and how they are aromatic. So we already discussed about benzene, naphthalene and anthracene. They are aromatic in nature. Now this is cyclopropynyl cation. Let's check whether it is aromatic or not. So we need to check the condition. We need to check the 4 condition. Is it cyclic? Yes, there is a cyclic form and there is conjugation as well. Pi, sigma, positive, sigma, pi. There is conjugation as well and planar as well. So now satisfy the Hockel's rule. There are 2 pi electron system. There are 2 pi electron. So when n equals to 0, we will get 2 pi 4 into 0 plus 2, that is 2 pi electron. So the given compound is aromatic. So while talking about the conjugation, you should check pi, sigma, pi condition, pi, sigma, positive charge condition, pi, sigma, negative charge, pi, sigma, lone pair. So these are the condition for conjugation. If there is such condition in organic compound, there will be conjugation in organic compound. Another example, let me take another example. So minus. So is this compound is aromatic or not? Let's check the aromaticity. This is cyclic. There is conjugation as well and planar as well. Now check the Hockel rule. Pi, sigma, negative, sigma, pi. So altogether how many pi electron are there? So this negative charge is also involving in conjugation. That's why we need to count this negative charge in pi electron as well. Altogether we have 4 pi electrons. So 4 into 1 equals to 4 pi electron. So 4 pi electron means it do not obeys Hockel's rule. It obeys 4n pi electron system, SYSTEM. That's why this is cyclopropynyl anion is anti-aromatic compound. Anti-aromatic compound. Now let's check the aromaticity of this compound. This is pyrrole. So first condition is it is cyclic. There is conjugation as well. And how there is conjugation, let me show you. This is pi, sigma. Our nitrogen has lone pair, pi, sigma, lone pair, sigma, pi. Yes, there is a good conjugation in the ring. That's why there is conjugation as well. And this is planar as well, planarity. For the planarity, we need to check the hybridization. sp2 hybridize. All the atom are sp2 hybridize. Now at last we are going to satisfying the Hawkins rule, that is 4n plus 2 pi electron system. So how many pi electron are there in case of pyrrole? This is pyrrole, right? So altogether there are 1 2 4, the 2 pi electron 4, and these lone pair are also involving in conjugation. That's why we need to count these lone pair as well in pi electron. That's why altogether we have 6 pi electron. So when n equals to 1, we get the value 4 into 1 plus 2, that is 6 pi. So pyrrole is aromatic. In the same manner, we can check for pyridine as well. So this is the structure of pyridine. Let's check whether it is aromatic or not. So it is cyclic. There is conjugation as well. Pi, sigma, pi, sigma, pi, sigma. And planar as well. All the carbon and nitrogen are sp2 hybridized. And 4n plus 2 pi Hawkins rule. Let's satisfy the Hawkins rule. Altogether there are 1 2 3 6 pi electrons. So when n equals to 1, we get the value 4 into 1 plus 2, that is 6 pi electron. That's why pyridine is also aromatic. Some of the students might do mistake here in counting the pi electron. Some of the students might count the lone pair of nitrogen as well. In that case, the lone pair are not counted because they are not involving in resonance. Remember the point, if the lone pair, if the charge are involving in resonance, we need to count them in pi electron. Otherwise, we should not count negative charge and lone pair in pi electron. In the same manner, thiophene. This is thiophene, and this thiophene is also aromatic. In order to show the aromaticity, you need to check this is cyclic and this is planar. There is conjugation as well. Pi, sigma, lone pair, sigma, pi. Yes, there is conjugation as well. Altogether there are 6 pi electron. So we will get 6 pi electron when n equals to 1. That's why thiophene is also aromatic compound. Another example, let me try another example, that is furan. So this is also same as thiophene. This is also cyclic, planar, conjugation, and obeys Hawkins rule. There are 6 pi electron. So we can satisfy Hawkins rule in this way as well. 4n plus 2 equals to how many pi electron are there? 1 pi bond, another pi bond, 4 pi electron, including these 2 lone pair, there are altogether 6 pi electron. And 4n equals to 4 and n equals to 1. If we get the n positive value of n positive whole number, that the compound will be aromatic. If we get the value n in decimal or in fraction, in that case the compound will not be aromatic. This is another way to check the Hawkins rule, satisfy the Hawkins rule. Now cyclopropanone. There is another example. Cyclopropanone, double bond O. So let's check the aromaticity of this compound, whether this cyclopropanone is aromatic or not. So this is also cyclic, there is also conjugation, and this is also planar. And let's satisfy the Hawkins rule. 4n plus 2 pi electron system. So as you are seeing, the compound is cyclic. Let me show you the conjugation as well. This is pi bond, this is pi bond, this is our sigma bond, and again there is sigma. So student might have confusion. There is no any conjugation in this ring system. Let me draw it again to make you clear. So this is our pi bond, here is our double bond O, and to show the conjugation, in order to be aromatic, there must be conjugation in whole ring. So अब यहाँनिर चाहिँ के हुन्छ भन्दाखेरिमा पाई सिग्मा, अब यो पाई इलेक्ट्रोन, यो कार्बन र अक्सिजनको इलेक्ट्रोनेगेटिभ यहाँ नेगेटिभिटी कम्पेयर गर्दा अक्सिजनको इलेक्ट्रोनेगेटिभिटी बढी हुन्छ. सो this pi electron will shifted to this oxygen in order to gain negative charge, and this carbon is going to get positive charge, and this is our sigma. So pi sigma positive sigma. So yes, there is a conjugation. So this is cyclic, this is there is conjugation and planar as well. So altogether, how many pi electron are there? There are 2 pi electron. So in order to get 2 pi electron, the value of n is 0. So you can satisfy in this way as well. 4n plus 2 equals to how many pi electron? Only 2. Please don't count this pi electron in total pi electron, because this is not involving in conjugation. Many of the students do that mistake. So 4n equals to 0, 4n equals to 0, n equals to 0. So the compound is aromatic because the value of n ranges from 0, 1, 2 to that is positive whole number. So this compound is also aromatic. Let's check the aromaticity of this 4 compound as well. First of all, cyclohepta triennyl cation. So first of all, we need to check whether it is cyclic or not. It is cyclic in nature, and is there any conjugation or not? Pi sigma positive charge, sigma pi sigma pi sigma pi again sigma pi sigma. Yes, there is conjugation along the ring. And planarity, planar. So all the carbon are sp2 hybridized carbocation. Here the carbon has positive charge. This is also sp2 hybridized, so it is planar as well. Another condition is Huckel's rule. 4n plus 2 equals to how many pi electron? 1, 2, 3 pi bond. So we have how many pi electrons? 6 pi electron. So n equals to, we will get, after solving this equation, we will get n equals to 1. So n equals to 1 is the possible value which satisfy the Huckel's rule. That's why this cyclohepta triennyl cation is aromatic compound, aromatic in nature. So let's try cyclohepta triennyl anion. So it is cyclic, it is planar, and there is conjugation as well. Conjugation pi sigma negative sigma pi sigma pi sigma. So there is conjugation. Now let's check the Huckel's rule. How many pi electron are there? 1, 2, 3, 6. And this negative charge is also involving in resonance. That's why we need to count this negative charge in total pi electron as well. So altogether there are 8 pi electron. So it do not obeys Huckel's rule. 4n plus 2 equals to 8. 4n equals to 6. N equals to 6 by 4. So the value of n is in fraction here. That's why it do not obey Huckel's rule. But it obeys 4n pi electron system. 4n pi electron system, that is 4 into 2 equals to 8. That's why this is anti-aromatic. Anti-aromatic. For anti-aromaticity, the compound must be cyclic, planar, conjugation, and obey 4n pi electron system. That's why cyclohepta triennyl anion is anti-aromatic. So cyclohepta triene and this is cyclic, and there is no conjugation, there is no planarity. There is no any planar form because this carbon is sp3 hybridized, as we are seeing. Yes, 1 2 3 4 sigma bond, sp3 hybridization. That's why cycloheptatriene is not aromatic. If there is no conjugation, if there is no planarity, then we should not satisfy the Hockel-Sul. We should not go for the Hockel-Sul. Hockel-Sul हामीले हेर्नै पर्दैन, किनकि यदि कम्पाउन्डमा प्लेनरिटी नै छैन, यदि कम्पाउन्डमा कन्जुगेसन नै छैन भने Hockel-Sul चेक गर्नै पर्दैन. द कम्पाउन्ड विल बी not aromatic. So if it is not aromatic, it is non-aromatic compound. If it is not aromatic, it will be not anti-aromatic as well. So it will be non-aromatic. Non-aromatic. Now let's go for the cyclooctatetraene. This is cyclic in nature. There is a conjugation, as you are seeing, pi, sigma, pi, sigma, pi, sigma, pi, sigma. There is good conjugation, and all the carbon are sp2 hybridized as well. Now finally we need to satisfy Hockel-Sul. These three conditions for the aromatic compound are satisfied here. Now finally we need to satisfy Hockel-Sul as well. 4n plus 2 equals to how many pi electron? Altogether we have 4 pi bond, that's why there are 8 pi electron. 4n equals to 6, n equals to 6 by 4, which comes in fraction, which is not possible according to Hockel. So it do not obeys the Hockel rule, that's why it is not aromatic. But it obeys 4n pi electron system, that is 4 into 2 equals to 8. That's why it is anti-aromatic. This is all about aromatic compound, non-aromatic compound, and anti-aromatic compound. Finally, I will conclude my lecture by saying a compound is aromatic if and only if it is cyclic, planar, and must have conjugation, obeys Hockel-Sul. Obeys Hockel-Sul. That is 4n plus 2 pi electron system. So these are the properties of aromatic compound. The additional properties of aromatic compound are they bond with sooty flame, BURNS bonds with sooty flame, FLAME, because due to the higher proportion of carbon on them. Another important property is they prefer to go for electrophilic substitution reaction rather than addition reaction. Favors ADD and electrophilic addition reaction rather than electrophilic substitution reaction. Another important point is they are highly stable because of resonance. So if they are highly stable, they are less reactive. I already told you in organic chemistry, the most stable compound are aromatic compound and the most unstable compound are anti-aromatic compound. This is all about aromatic, anti-aromatic and non-aromatic compound. Thank you.